So far, we have been introduced to various deterministic protocols for multiple access at the data link layer. Specifically, we saw time division multiplexing and frequency division multiplexing, which are the classical multiplexing and pre-allotment schemes. In this module, we shall start with random access protocols, which form the basis for the probabilistic schemes which are widely used in various LANs and other channel access schemes. We shall cover the basic idea that governs the randomness in terms of access. Then we look at how the packet attempts are made, and if the packets are being attempted to be sent randomly, then collisions do happen. Then how the collisions can be managed in these random access protocols. An extensive work has been assigned to random access protocols in Kuros and Ross, and the theoretical foundation has been very well laid in Anurag Kumar classical book, Communication Networking and Analytical Approach. So what's the basic idea? The basic idea of random access protocols is literally incorporate no intelligence or no algorithm at all. In simple terms, when a node in a network has data to be sent, just send it and avail the full transmission rate of the channel. There is no priori coordination between the nodes. As a consequence, accidents do happen. These accidents, also called the collisions, are fully understandable because no a priori commitment was made between the nodes. Hence, when collisions happen, nodes should have a mechanism to recover from there. In this two-dimensional plot, we see a relationship that exists between time and space axes if we are using random access protocols. The points that you see randomly distributed are referring to the locations in a network from where the nodes or the computers are transmitting at various instances of time. As an example, you see the point which has been highlighted here. It is at the intersection of time t and space y. Similar to it, there are other nodes which are transmitting at various instances of time and space. If the transmissions overlap between two time-space points, it is termed as collision. So if you want to understand the current state of affairs in a network in terms of successful transmissions and collisions, it's a very good idea to think about visualization as a 2D plot just shown to you now. When the collisions happen, it becomes very important to understand that detection of collision is the first step that lets all the participating nodes know that the channel access attempts that they're making is causing collision. So they need to back out. Various collision detection mechanisms could be incorporated. For example, the change in the voltage on the communication channel. If it's wired, it's easier. If it is wireless, it's a little bit tricky. Or the non-arrival of the acknowledgement also implies that collision must have taken place. Naturally, if collisions start to happen frequently, then it should caution the nodes to throttle down their transmission rates. In simple words, when a node transmits and somehow it gets to know through any means that we've just seen that collisions has taken place, so it has to back out from the ongoing transmission. It should wait and should reattempt at a later time. This is one of the widely adopted strategies for collision management in various protocols, for example, Aloha, slotted Aloha, and Ethernet. We'll see them in due course of time.